Hello, back to Energy 101, and today we're talking about electric power, part of the energy conversion process. And specifically, we're looking at electric power, which takes heat and actually the chemical energy gets converted to heat, and we're converting it at first to work with a shaft that turns then an electric generator. So this is the primary energy conversion process we're looking at for electric power plants, taking fossil fuel and others, as we'll see in just a minute, but it's dominated by fossil fuels that we burn and produce thermal energy and convert it to electricity. That is a very nice form of energy to use and to transport, and it's incredibly versatile, and the percentage of the energy that we're using that's being converted to electricity is going up, as we'll see in a few minutes. We saw this last time, that we're talking about a power system that takes in thermal energy from the combustion of fuels or the nuclear reaction of uranium-235, and then goes to boil steam, and that we convert some of that energy to electricity, and we can throw the rest of it away to the river or to the atmosphere. I've shown it about a third, and this is about what is produced and the split that we have in today's electric power industry, which we'll see in just a minute. This is what we call a spaghetti chart. Don't get intimidated by it. Let's walk through it and get some nuggets out of this spaghetti diagram. It's got a lot of information on it, and there's no reason to get intimidated by it and get confused. But let's look and see what we're talking about with the electric power industry. First, from the big picture, we're talking about the raw forms, natural forms of energy over here on the left, and we're talking about the utilization of those over here on the right, that by split up as residential, commercial buildings being office buildings and shops, and then industry, which is manufacturing, that produces goods and services and products, and then transportation is the way it's split up on the right-hand side. So we're focusing today on electric power generation. So let's follow the flow of what comes into the electric power conversion process and what leaves the electric conversion plants that produces the electricity. So on the one hand, we see the biggest energy input is coal here. It's flat and black, and that's the biggest piece of the energy input to our electric power generating infrastructure. And next we move up to the natural gas. Natural gas is the next one, and that's blue right here, and that is another big chunk. We see a very little bit of it there, a real sliver by geothermal, and which you can see the numbers here, and then wind. Wind is the other one right there. Here's the geothermal, and these percentages you notice are actually, these aren't percentages. Let's talk about that just a minute. The overall input is 97.3 quads. What's a quad? A quad is 10 to the 15th BTU, so that's a quad. It makes it convenient because it's essentially 100. So all of these numbers, like this wind number, that's 1.17 quads, is essentially converts when you divide it by 100, or 97.3 converts essentially to percentages. So the wind energy, that number should look familiar as the percent of the electrical energy that we get from wind. Hydro is the next one up here. Hydro is renewable, and that's about 3% as we've seen before. And then we have solar, nuclear. Let's go to nuclear first. Nuclear, you notice, is a big chunk, and that's once you build those nuclear plants, they're expensive to build but cheap to operate, and you run them a lot, as we'll see later on. And the last one up here is solar, which is a pretty small fraction denoted by the thin line here that goes in. So those are all of the energy inputs over here on the left-hand side into the power plants. And you can see about what fraction of the electric power generation is fueled by which energy input. On the output side, of course, the whole purpose here is to generate electricity. And that's shown by the gold line up here. And you notice that you get about, we're getting about 12 quads out in electricity, but notice the waste heat out here. The waste heat that we're throwing away is 26, which is about twice. So that's about the same as what we looked at in the last slide, when we saw that we're throwing away about 2 units of energy for every 3 we put in, converting 1 to electricity. And that's essentially what happens is for our electric power generation industry as a whole. And so we're now equipped to understand why we throw so much of this energy away. It's because it's thermal energy that we get from burning. Most of this fuel is fossil fuels, not all of it. But even the nuclear is being converted to thermal energy. It has a quality of significantly less than 1. Second law of thermodynamics says that we cannot convert all of it to electricity and not have any waste heat. Second law of thermodynamics dictates that we degrade some of it, a large fraction of it in general, and throw it away to the atmosphere. We say thrown away, rejected the atmosphere, which is the rivers and the atmospheric air also. So this basically we're in a situation to interpret what all that means. Now, once we generate that electricity, then we see that what happens to that electricity. Excuse me, I got to turn my cell phone off here. Okay. So where does this electricity go? Well, it goes to the residential, it goes down here to commercial, the office buildings and shops, and it goes to the manufacturing industry. That's where the electricity goes. But before it ever gets there, we're throwing away 2/3 of the energy that we put into the power plant to produce that electricity. And electricity is a nice one, as I've said, a nice form of energy, and it's one that has a lot of value to it because it can be easily transported, and we also have a situation where we can use it to do a lot of things. The other things that we might look at while we're looking at this chart is petroleum down here. Petroleum, oil, where does most of it go? We see most of it goes to transportation. And again, to show the example of the second law at work, you notice that we're putting all of this petroleum, oil into the transportation sector for turning shafts to rotate our wheels and buses and cars and trucks. And about 80% of that, or 75% of that energy is being thrown away here, over here on the bottom. And so that is again a result of the second law of thermodynamics. Only about 25% of it gets converted into work that goes to drive our transportation system that we need. But again, the second law of thermodynamics is dictating that we throw away a lot of that thermal energy that we get out of burning that oil over here and converting it to work, because we're using a quality of energy less than 1 to produce a quality of energy of 1. So there are a lot of information on this chart, and you can look at these numbers. You can look at the small slivers that make up very little. You notice the solar energy down here. A lot of it goes to industry, and some of it goes into the grid. We can follow the biomass. Biomass is primarily in burning wood waste that we have, and even fireplaces, and that goes into industry. The pulp and paper industry utilizes a lot of their waste that comes out of their pulp and paper industry and manufacturing process to produce steam and to produce electricity to help their manufacturing process. So it looks like a complicated chart, but it's got a lot of good information once you get down to looking at the details. Lastly, we'll just look at this chart quickly. This gives the trend and shows for the electric power industry here. This is the total power industry over time, and how much of the electricity is being produced for each sector. Coal is the black, petroleum is the red, natural gas blue, the light green is nuclear, hydroelectric is a renewable, that's dams, and then we have other renewable other than hydroelectric, because that's renewable also. The other renewable is mainly wind and solar, and we see it's up here red, and it's a very small sliver. But you can see the trends. Notice that most of the growth in the electric power industry, the fuels used, was coal until we got to about 2008 in the recession, and then the recession meant that people were using less electricity, and they mainly cut down the coal-fired power plants. They have a choice of which ones to run, so they turned the coal-fired power plants down and kept running and increasing the amount of gas. Notice the amount of gas in the blue has been trending upward. We're getting more and more from gas, and that trend is continuing. And the nuclear we haven't built any nuclear plants since in a long time, since basically the 80s, but we're able to run them more than we used to because they're getting more reliable. And then you get the hydro, which is, you take the hydro if you can get it, because once you build the dam, it's free energy. Doesn't cost you anything for the energy, the water's there. So this shows you the trend of all of these fuels that we're using for the electric power industry. So that gives us a quick overview of the electric power industry and where the fuel is coming from and how much of the energy we're throwing away to the atmosphere as a result of the second law of thermodynamics. So that concludes that section, and we'll look a little more at the electric power industry from time to time. Thank you.